Okay, so now I'm going to actually start calculating some of these because this is obviously a mess. I'm going to start with this Christoffel symbol right here. 1/2 G. Alright. Now there's no R, the negative sign and the R squared aren't going to play into this because they'll cancel here. So we're just going to do 1/2 1 over sine squared phi. Sine squared phi, that's just 2 sine of phi. Cosine phi. 2 cancel. Sine cancel. I accidentally erased we know that's 3 symbols we've worked out now. I don't know why I bothered with that extra red line, because I was just going to erase it. So now we can rewrite this as, well, let's focus on these two terms right here. Equals negative sign, it's cosine, negative sign, plus, well, those are just going to cancel there. Yay! And that's just going to go to 1. Yay! Negative 1, that's just going to go to 1. So this whole thing right there is just 1. Yay! So we can actually I sincerely hope that is the case. Yeah, that checks out. It's not a unit problem. Plus 1. There we go. Yeah, that checks out because the inverse units is 1 over r squared, and that's the curvature units. So that's okay. That's good. We're gonna go on ahead and work out r theta or phi equals 1/2 GRR negative G. That's just 1/2 negative B, because GRR is negative B, so we're going to take negative 1/2 B. So that'll cancel there. And then negative r squared derivative negative 2r equals negative r over b. Let me 1, 2. Yeah. I did do myself in a little bit by using that metric signature, but I could have stopped myself, but I didn't. Alright, negative r over b. So now we can write that component as a r negative r over b plus 1 plus and we can actually need 1 over b pull out plus b prime r this component reduces to that. I'm going to go ahead and write down this term over here. So any of the 0, 0 and the RR terms it's just G A over R. So in that case, 0, 0 R is equal to A. Is equal to B prime over 2B. So we're going to rewrite these terms over here as A over 2A plus B prime over 2B. I'm going to write this as negative minus negative R. That's actually going to cancel that and make that go to negative. So we can rewrite actually we're going to get rid of that pesky negative sign. So we can simplify that little 5 pi metric term, curvature tensor term component as that right there. So I'm going to rewrite that over here. One interesting thing to note, in the limit that we know we're doing something right, and the limit that the source vanishes, all the coordinate dependence vanishes. So the derivatives here will actually go to 0. And b will approach 1, which will make this whole curvature tensor component go to 0. So in the flats, in the limit that our source vanishes, our curvature tensor vanishes, which is good. That's what we want. We want the curvature to vanish, the space-time, the gravity to vanish once you get rid of the source. I love that this is... Well, I think there's simpler solutions, but I love that this is like considered one of the simplest solutions of Einstein's equations. I think like the curved, the FRW metric is slightly simpler if you ignore the curvature constant. Actually, it's quite simpler. Make sure I copied that right. Okay, so correspondingly, we're going to we're going to simplify these now. Let's look at, we need to know R sub 0, 0. We need to know wait, we already determined that one. We need to know, we need to know That's all we need. So we only need one more component, and then we can plug all this in. 1/2 GRR, GR negative equals 1/2 BA. So we know that already. So we're just going to set all these curvature tensor components to 0. Let me make sure I did that right. Yeah, okay, I did. Plus, what is R? Okay, I keep making that match. Okay, can't help it. Plus equals 0. That's our first equation. I wrote 0 equals twice. And 0 equals negative R. 2A plus there's a small chance I don't think I have, but there's a small chance that I had messed up on the RR component. If I have, I'm not entirely sure that we really even need it, because that first equation looks like it has enough constraints, but we're going to see. I think, again, I have done pretty good so far. Alright. And 0 equals, we're going to multiply all that by a factor of b. B minus 1 plus 1/2 R over 2 B over B minus A over A. Yeah, okay. So those are our 3 equations. I think I'm going to get rid of that. And again, the fourth one would be redundant for time constraints. Again, I'm not going to go over it tonight. I think it's obvious I could prove it if I willed so.